All right, this video will cover notes for section 5.5, which deals with special types of factoring. In this first example, we are asked to multiply a plus b times a minus b. And we're going to multiply using those same methods that we used in our previous section, the FOIL method. First terms, a times a will give us a squared. Our outer terms, a times minus b, gives us negative ab. The inner terms, b times a gives us ab. And then the last term, b times minus b, gives us negative b squared. Now, another way that we could write this type of solution when we have the sum and the difference of the same terms, in this case, a plus b and a minus b, we could write this as a special case, and it's called the difference of perfect square numbers. We factor them in a special way. Every time we have a difference of perfect square numbers, we will factor them by squaring the a term and then subtracting the b term squared. In this next example, we have a plus b raised to the second power. That's a plus b squared. And we would expand this first. Remember, squaring a number or squaring a term is just multiplying that term by itself. So a plus b times a plus b, and then we're going to multiply. We'll use the FOIL method. First term times first term will give us a squared. The outer terms, a times b, gives us ab. The inner terms, b times a, we'll write in alphabetical order again, a, b. And then the last term, b times b, would give us b squared. And when we simplify, we would add these two middle terms together. AB plus AB gives us 2AB. We carry down our a squared in front, carry down our b squared behind, and we'll get a squared plus 2ab plus b squared. I skipped this part in the previous example. The ab and the minus ab cancel each other out. And that's how we're left with a squared minus b squared. All right, let's look at the next example. Look, we have 25 minus y squared. Now, when we have two terms, we're taking the difference of them, and both of those numbers are perfect squares. This is that special case from before, where we have a difference of perfect square numbers. What you want to do is identify your a term and your b term. Remember from before, we had a squared minus b squared, right? So we're looking for that a term and that b term. And once we find out what that a term and that b term are, we would factor it using this method. We're going to take the sum of the a and b terms, so a plus b, and then we'll take the difference of the a and b terms, a minus b. Now, a just stands for the number that we're squaring to get 25. What are we squaring to get 25? And that's 5. The b term is the term that we're squaring to get y squared. What do we square to get y squared? And it's y. After you figure out what a is and b is, then you factor them using this method. Everywhere a is, we plug in 5. So as we can see, we wrote 5 here. So 5 plus and 5 minus. Our b term we said was y. So everywhere y is, well, everywhere b is, we're going to replace that term with y. So here we have plus y and minus y. We factor that difference of perfect squares as 5 plus y and 5 minus y. In the next example, we want to identify a and b again. What do we square in order to get 9z squared plus 64? Now, the key here is that we have a plus in between these perfect squares. So although 9 is a perfect square number, that's 3. Z squared is perfect square number, that will be z. And 64 is also a perfect square. 8 times 8 gives us 64. The issue is that we have a plus in between those perfect square numbers. So we couldn't factor this using our difference of perfect square process. This term would not be able to be factored any further. So we write it as being prime. In the next example, we see perfect square numbers with a minus between them. So we can identify our A and our B term for this next example. What do we square in order to get 9x squared? So 9, we know is 3 times 3, and x squared, we multiply x times itself. So together, that perfect square term would be 3x. Now, what do we square to get 4y squared? 4, that number we multiply by itself to get 4 is 2. And then y squared, the term that we multiply by itself to get y squared is y. So our a term is 3x, our b term is 2y. And we would substitute 3x and 2y into our a plus b and a minus b format. So everywhere a is, we're going to substitute 3x. We have 3x plus and 3x minus, and then our 2y for b, 2y and minus 2y. But this is our answer. All right, now we actually see a difference of perfect squares again for this next example. We have x to the fourth power minus 16. So we identify our a term as being x squared. That's the term we square in order to get x to the fourth power. And then 16, we square 4. We raise 4 to the second power in order to get 16. So we're going to factor using this format, the a plus b and the a minus b format. Everywhere a is, we're going to substitute x squared. So we put our minus in front this time. But everywhere a is, we're going to put x squared. And our b term is 4. So we have minus 4 and plus 4. All right, so after we identify our x squared minus 4, our x squared plus 4, we'll notice that we have a difference of perfect squares again. This x squared minus 4, we can factor that term a little bit more by identifying our a and b terms, x squared. We multiply x in order to get that first term, x squared. And the 4, we square or multiply 2 by itself in order to get 4. So we factor using x for a and b and 2 for b. So we have x plus 2, this is our a term squared, and x minus 2, this is our b term. So after we factor the x squared minus 4 using x plus 2 and x minus 2, we just copy down the third term, which would be x squared plus 4. But this is our solution. All right, in the next example, we are going to wind up with a difference of perfect square terms, but first we have a GCF that we need to factor out. We have a common factor. We can factor x from both of these terms. And when we factor x from 100x cubed, we get 100x squared in parentheses. We factor x from the minus x, we get 1 in the parentheses. So we carry down this x, and 100x squared minus 1, that is a difference of perfect square terms. We can identify the a and the b terms. The a term, 100x squared, what do we square in order to get 100x squared? It would be 10x. And the number we square in order to get 1 would be 1. 1 raised to the second power is just going to be 1. So our a term is 10x. We plug in 10x plus and 10x minus. And our parentheses, and our b term is 1. So we put positive 1 and that minus 1. So this is our solution. All right, in our next example, we have a GCF, a common factor that we need to factor out at the beginning. Our z to the second power. We factor z squared from both of these terms. When we factor z squared from 64, z to the fourth power, we get 64z squared in parentheses. And when we factor z squared from the minus 49z squared, we get minus 49 in parentheses. So carry down your z squared, and 64z squared and 49, both of those are perfect square terms. So we can identify the a term and the b term in order to factor using that format, the a plus b and the a minus b format. Our a term would be 8z. 8 times 8 gives us 64, and z times z gives us z squared. And then 49, our b term is going to be 7. We square 7. 7 times 7 gives us 49. So when we substitute 8z for a and 7 for b, we'll get 8z plus 7 and 8z minus 7. And this is our answer. All right, we have a trinomial for the next problem, 9z squared minus 24z plus 16. This 9z squared, we factor using 3z and 3z. 9 is a perfect square number. 3 times 3 gives us 9. And z squared, we use z and z. And then to factor 16, we use minus 4 and positive 4. Notice we have the same terms in parentheses twice. So another way that we could write that 3z minus 4 times 3z minus 4 is just 3z minus 4 squared. Now, similarly, in the next example, we see 64a squared as our first term. We're going to factor that 64a squared using 8a and 8a. We know 8 times 8 gives us 64, and a times a gives us 8 squared. And then b squared, we're factoring using a minus b and a minus b. We're using minus in front of both of those b terms because our middle term is negative 16. All right, now notice in parentheses you have 8a minus b times 8a minus b. That's the same terms twice. So we can rewrite that as 8a minus b squared. Now in the next example, we have a GCF, a common factor that we can factor from all three of these terms. So we first factor out xy. From the first term, from 4x cubed y, we're left with 4x squared. When we factor xy, from 12x squared y squared, we get positive 12xy in parentheses. And when we factor xy from 9xy cubed, we get 9y squared in parentheses. So you carry down that xy that you factored out. And now we're going to factor that first term, that 4x squared, using 2x and 2x. And then we're going to factor that last term, the 9y squared, using 3y and 3y. Now, the 2x plus 3y, we see that duplicated. So we can rewrite that 2x plus 3y raised to the second power and carry down your xy in front of that term. All right, in the next example, we have a GCF. We have a that we can factor from both of these terms, from both of these terms. When we factor a from a cubed, we get a squared in parentheses. And when we factor a from this minus ab squared, we get minus b squared in parentheses. Carry down your a in front of the parentheses, and our a squared and b squared, that's just a difference of perfect square terms again. Our a term, what are we squaring to get that a squared? Is a and a. And then our b term, we're squaring b and b. And remember, we factor using a plus b and a minus b. That's our special case, the difference of perfect square terms. All right, we have a trinomial for the next example. Notice that this 3x squared, this 3 is not a perfect square number, it's a prime number. So we factor 3x squared using 3x and 1x. And then we factor 8 using 2 and 4. Now remember, you can always FOIL this to check and make sure that you factored correctly. But your answer is 3x plus 2 times x plus 4. Now, although in this next example we see perfect square numbers, we don't have a minus in between those two terms. It's a plus sign. So we couldn't factor using that special case, that a plus b and a minus b format. This cannot be factored any further, so we write it as being prime. All right, the next example, we have a squared times b squared minus c squared times d squared. So this is a difference of perfect square numbers. We can identify our a and b terms. Our a term, what are we squaring to get a squared, b squared? We're squaring ab. And the b term, c squared, d squared, we're squaring cd to get that second term. So we factor using AB plus and AB minus, and then put your CD in space of the second term. But this is our answer. AB plus CD times AB minus CD. Now this is the last example. We're going to stop here.